All right, so today we're going to talk about how to solve a system of equations. And before we actually solve a system of equations, we're going to talk about the different types of solutions. And we're going to look at that graphically. All right, so here's what I mean by that. In a system of linear equations, we'll have either one of three solutions. All right, so just keep in mind that for these systems, we're working with okay, well, these are just types of equations, just to make sure. Okay, we're all on the same page. So if we look at this first, and these are linear equations. 2x plus 3y is equal to 6. Okay. First off, it would be a linear equation. The reason why this is a linear equation, because if you look at the variables, right, we have a variable x, a variable y. The highest power on the variable is 1, right? So that turns it to be a linear equation. Since we have two variables, there's an x and a y variable, this would be a linear equation in two variables. All right. If we take a look at another example, x plus 2y minus 3z is equal to 9. Right? This would also be a linear equation because if we look at our exponents, the largest exponent is a 1, right? So that would make it a linear, well, that would classify it as a linear equation. And then this linear equation has three variables. There's an x variable, a y variable, and a z variable. So this would be a linear equation in three variables. Okay. Now, you can have as many variables as you want. But the thing we want to keep in mind here is that the largest power for any one of those variables is the understood one. So we're going to look at the linear equation in two variables, okay, and their solution. So linear equation right? So if we were to take two linear equations, we're going to graph them. So I'm going to just call one of the linear equations L1. So keep in mind these things are in an XY axis. I'm going to call this L1. And I'm going to graph another equation. I'm going to call that L2. The solution of any system of linear equations is where those two equations intersect. Right? So right here where they intersect, that's called the solution. Okay? And the solution is going to have an X, Y ordered pair format. Right? And this would be also called a dependent solution. Because one equation is dependent upon the other equation. We can also graph a line, right? So this is our second type of solution. So I can graph one line, I'm going to call it L1. And if I graph another line, L2, and that line fits exactly on top of the other line, okay, then this is said to be an all real number solution. Okay, because if I graph one line and if I graph another line and one line fits on top of the other, they intersect at every point, right? And then lastly, if I were to graph one line, all right, and if I were to graph another line, and the two lines never intersect, right, then I'm going to have a no solution or an inconsistent. So let me just make a correction. So this would be equal to, all right, so for this first example, that's actually going to be equal to 1. Because I'm looking at the homework and they got, it says solve an inconsistent, dependent, or does it have one solution? So for this first example, that should not be dependent. That's going to be one solution, right? Because there's only one ordered pair solution. For the second setup, if you graph one line, you graph the other line, both of the lines are the same, that's the dependent. And if you graph both lines and they never intersect, that is the inconsistent. All right, now, so if you took the prerequisite for this course, intermediate algebra, there were like I think you looked at 2 ways to solve. You could solve either by graphing, okay, which is basically what we just had taken a look at, right? Graph the 2 lines. You could find the solution analytically by either using the elimination or substitution method. Something that's very rarely taught, there's something called Cramer's rule. And you can solve using Cramer's rule, or what we're going to do in this course, we're going to solve using technology, which is the TI calculator. All right, so we're not going to use any graphing or any algebraic or analytic method. We're going to use a calculator. All right. So let's take a look at an example. All right, so we want to solve the system x plus 4y minus 4z is equal to -1. 2x minus 4y minus 3z is equal to -3. And -2x plus 2y plus z is equal to 0. All right, so we're going to solve this system, and we're going to use a calculator. So I'm going to bring that up. All right, so we're going to enter the system into the calculator. But in doing that, we're going to have to convert the system to a matrix. So I'm just going to explain a matrix. All right, so a matrix is denoted by its rows and columns. So whenever you describe a matrix, you have to describe it by its rows first and its columns second. Right? So we're going to take this linear equations in 3 variables, we're going to convert it to a matrix. So first, I'm going to count out the number of rows. So we have 3 equations, so we're going to have 3 rows. And then we're going to have 4 columns. We have a column for X, a column for Y, a column for Z, and then a column for our equals. Right? So we're going to convert this to a 3 by 4 matrix. All right, so it's going to have 3 rows and 4 columns. The next thing, I just want to make sure that in my first column, I put only X variables. In the second column, I only put Y variables. In the third column, I only put Z variables. And in the fourth column, I put whatever the equation is set equal to. Right? So now I'm going to go back to the system. I'm simply going to pull out the coefficients. Right? So I'm going to take this first row, right? X plus 4y minus 4z is equal to 1. And I'm simply going to list out its coefficients. So my first row, I should have 1, 4, -4, and -1. Right? So that's actually equation, right? X plus 4y minus 4z equal to 1. I'm going to do the same thing for that second equation. I'm going to simply write out its coefficients. So we have 2x minus 4y minus 3z is equal to -3. And then I'm going to write out the coefficients for the last row. So we have -2, 2, 1, and 0. So we're going to put that into the calculator. All right. So I'm going to turn the calculator on. And now I want to go into matrix. And on my particular calculator, matrix is above the inverse, x inverse, and it's a second function. So I'm going to hit second and matrix. Now, once you go into matrix, you have at the top, I have names, I have math, and I have edit. I want to go over to math. Okay. And I'm always going to use matrix A. All right, so since matrix A is already highlighted, I'm going to press enter. So now from this point, we have to put in the dimensions of the matrix. So this is a 3 by 4 matrix. So we're going to put in 3 rows, and I'm going to hit enter, 4 columns, and I'm going to hit enter. Now, one thing about the calculator is that it only shows 3 columns at a time, but if you kind of scroll forward, you can kind of see that 4th column. All right, so now we're going to put in our coefficients. And for every element, you just want to hit enter. Make sure if you're putting in a negative number, you want to make sure that you're using the negative key, okay, and not the minus key, because it will give you an error. All right, so I believe I have everything entered. Let me just check that out. 1, 4, -4, -1. And this should actually be a 2. Okay, let me just check that again. 1, 4, -4, -1. All right, so I'm just kind of double checking my matrix of what I have written. Okay. All right, so now the way I'm actually checking this, once you enter in your matrix, if I go back into second and matrix, and under names, I'm simply hitting enter because I just want to look at matrix A. So I'm just looking at matrix A. I hit enter once, I hit enter again. Okay. And I'm just checking all of my coefficients. This way I can see all 4 of my columns. All right, so once you enter the matrix into the calculator, and I believe we did, okay. I use the matrix key. After you put your matrix into the calculator, the next and very most important step is you want to return to the home screen. All right, so I want to hit second and mode, which is actually the quit key. All right, so I'm at the home screen. And now the next thing we want to do is calculate the solution. All right, so I'm going to go back in the matrix. I'm going to scroll over to math. I'm going to scroll down to RREF. Now there's a REF and there's a RREF. You want to make sure that you use RREF. And that's short for reduced row echelon form. All right, so once we scroll down to RREF, you want to hit enter. And then we have to put in the matrix in which we want to reduce down. So I have to go back into matrix. So I'm going to hit second and inverse key, which gives me the matrix. Then you have to select the matrix you want. And here we want to select matrix A, so I'm going to hit enter. Close off your parenthesis. And then we're going to hit enter. And believe it or not, this actually gives us our solution. Okay. So let's just take a look at the output for a second. And this is what we get. I'm just going to write this on the side. 1, 0, 0, 1, 0, 1, 0.5, 0, 0, 1, 1. Okay. All right, and we put it in coefficients, and it actually gives us the solution as coefficients. So just remember that X was the first column, Y was the second column, Z was the third column, and equal was the last column. So if you look at this first row, that's actually an equation. And that equation is read as one X, or just X, plus 0Y, which is 0, plus 0Z, which is 0, is equal to 1. So that simplifies down to give us X is equal to 1. If you look at the second row, that's actually an equation, right? So it gives us 0x plus y, right? So 0x is 0, right? So for the next column, y has a coefficient of understood 1, so that's 1y, plus 0z, right? So 0z is 0, equal to 0.5. Right, so that tells us that y is equal to a half. So x is equal to 1, y is equal to a half, and this last equation tells us that z is equal to 1. So our ordered pair solution is 1, 1/2, 1. All right, so you put it in as a matrix, a coefficient matrix is what that actually is called. And once you use RREF, it gives you the answer also in a coefficient matrix. So just notice the diagonal ones that are going in this reduced form. All right, so this is if you have one solution. All right, because that's just one ordered pair solution. Now we're going to take a look at this example. And here again, we want to solve the system 2x, well, I'm gonna just use x plus y is equal to 2. And then for my second equation, I'm going to use 2x plus 2y is equal to 4. All right, so we're going to solve this system of equations in 2 variables. And we're pretty much going to use the same steps. We're going to convert this system to a matrix. We're going to put the matrix into the calculator. All right, and then we're going to use the matrix, the reduced echelon form of that matrix, to pull out the solution. All right. So upon converting this to a matrix, right, we have to list out the rows and the columns. So this thing has 2 rows and it has 3 columns. So this is going to be transformed into a 2 by 3 matrix. So we're going to write out the coefficients for that matrix. So we have 1, 1, 2, 2, 2, and 4. All right, so I'm going to put that in. So, and I am using these steps. So first thing we're going to do is we're going to enter in the matrix. So I'm going to go back into matrix. I'm going to go over to edit. All right, so this is a 2 by 3 matrix. And I'm going to put in the coefficients. 1, 1, 2. 2, 2, and 4. Right, and I am going to just check that. So 1, 1, 2, 2, 2, 4. All right, so now I'm going to calculate the solution. All right, so once we have entered the matrix into the calculator, okay, you must go back to the home screen. All right, so I use the quick key. So now I'm going to go back into the matrix. I'm going to scroll over to math. I'm going to scroll down to RREF. I'm going to hit enter. I'm going to insert matrix A, close off the parenthesis, and hit enter. All right, so we have used reduced row echelon form, and it has spit out that coefficient matrix. All right, so I'm going to write that down. So this is 1, 1, 2, and 0, 0, 0. So if I were to kind of read these things out, that first line or the first row would actually be an equation. I would have x plus y is equal to 2. And that doesn't really give me a solution for either x or for y. If that happens, you want to concentrate on the very last row. So notice for this very last row, I have all zeros. If your last row has all zeros, then this is an all real number solution. Okay. So what that means is if you were to grab both of these lines, the line for the first equation and the line for the second equation would be exactly the same. So notice on the first solution, we kind of pulled it out and we got nice equations. X was equal to 1, y was equal to a half, z was equal to 1. But for this equation, we looked at the last row and we got 0, 0, 1. Excuse me, we got all zeros. And whenever you get all zeros on the last row, that is an all real number solution. And now we're going to take a look at a no solution. And I have to make one up. Okay, so let's take a look at this example. Negative 2x plus y is equal to 5, and negative 2x plus y is equal to negative 3. Okay, and we're going to solve this system. Okay, so here again we have 2 rows and 3 columns, so we're going to convert this to a 2 by 3 matrix. So for our first row, we have negative 2, 1, and 5. For the second row, we have negative 2, 1, and negative 3. All right, so we're going to put these into the calculator. So I'm going to go in the matrix. I'm going to go over to edit. It's a 2 by 3, so our dimensions are the same. Negative 2, 1, 5, negative 2, 1, and negative 3. negative 2, 1, 5, negative 2, 1, and negative 3. All right. So I have the matrix in the calculator. Now I'm going to go back to the home screen. And now here's a trick you can do with your calculator. Instead of going back in the matrix and going to RREF, if you hit second and enter, it'll kind of scroll through the memory on your calculator. So if I hit second and enter, notice it brought up RREFA. And if I hit enter, right, it spit out a matrix. All right, so I'm going to write that down. So I have 1, negative 0.5, and 0, and then I have 0, 0, 1. So just as we put it in as a matrix, we can take it out as a matrix. So for that first row, that's actually an equation, and it is read as x minus 1/2 y is equal to 0. So that's neither solve for x nor y. But if we look at the last row, it's not all zeros, right? If it were all zeros, it would be an all real numbers solution. This has a last row of 0, 0, 1. Right? So this last row is actually like 0 is equal to 1, right? Because 0x plus 0y technically is 0, and I said equal to 1. 0 can never be equal to 1, so this is a no solution or inconsistent solution. So keep in mind the bottom rows. If the bottom row is all zeros, right, you have an all real number solution or a dependent solution. However, if the last row is 0 equal to 1, then it's a no solution or an inconsistent solution. All right, so those are the 3 type of solutions that you are going to encounter. All right, and here is something else that you're going to encounter. Let me see if I can find it. And it's this one. And now this one's similar to number 6 and 6.2. Okay, so we're going to solve negative 6x minus 9y is equal to negative 6. Negative 9y plus 6z is equal to negative 1. And 4x plus 6z is equal to 4. Okay, so we're going to convert this to a matrix. Now, on this one, you got to be careful because it looks as if it's a 3 by 3, right? 3 rows and 3 columns. But you have to look very carefully at your variables. Notice in this first equation, we have a x variable and a y variable, right? Negative 6x minus 9y equal -6. In the second equation, we have a y variable and a z variable. -9y plus 6z is equal to -1. And in the last equation, we have an x variable and a z variable. Right. So we actually have an x, a y, a z, and we have something set to equal. So this was actually a 3 by 4 matrix. Right. So if you're missing any variables, you must put in a filler 0. So here's what I mean by that. So for that first equation, we have -6x. So our first column is -6. We have -9y, so we have -9. Since we do not have a z variable, we're going to insert a 0. And then that's set equal to -6. So that is the first row. For the second row, we don't have an x variable, so we're going to put a 0 for x. -9y, so we have -9. We have a 6 for z, and it's set equal to -1. And then for our last equation, we have 4x. We don't have a y variable, so we must put in a filler y term for 0. We have a 6z, and that's set equal to 4. So this is our matrix. All right, so we're going to put that into the calculator. All right, so I'm going to go into matrix. I'm going to scroll over to edit. It's a 3 by 4 matrix. I'm going to put in the coefficients, -6, -9, 0, -6, 0. And I'm just going to check this out. -6, -9, 0, -6. All right, so I have the matrix entered in correctly. So now I'm going to calculate the solution. So I'm going to hit second. And enter. Okay, I'm going to hit second and enter again. Right, just kind of scrolling up through the memory. Right. All right, so I'm going to actually convert these decimals to fractions. So I'm going to go into math. Right, and I'm going to hit that first key. I'm going to change. It's going to attempt to change whatever is given into a fraction. And we have our solution matrix. So x is equal to 1/2. Z is equal to 1/3. Excuse me, y is equal to 1/3. And z is equal to 1/3. Right, so our solution is 1/2, 1/3, 1/3. All right, so you can solve any linear system of equations using that matrix solution in your calculator. All right, now also in the next section, 6.3, we are performing operations with matrices to add, subtract, multiply, and divide. Okay, so once you have the hang of putting the matrices in the calculator, right, performing the operations on them are not too difficult. So this is actually taken from 6.3, and the directions simply tell us to perform the given operations. So in this first example, we have matrix A is equal to 1, -6, 1, -5. B is equal to -2, 3, -4, and 5. And they would like us to add these two together. All right, so I'm going to put in matrix A. I'm going to put in matrix B in the calculator. And then we're simply going to use a calculator to add those two matrices together. Right, so if we look at the matrix A, that's going to be a 2 by 2, right? Because we got 2 rows, 2 columns. So I'm going to go to edit. Oops. I'm going to edit matrix A. It is a 2 by 2. I'm going to put in the values 1, -6, 1, and -5. I'm going to go back into matrix. I'm going to go over to edit, but this time I'm going to go down to matrix B and select enter. Matrix B is also a 2 by 2 matrix. I'm going to put in its elements, -2, 3, -4, and 5. Right, so I have matrix A in and I have matrix B in. I'm going to go back to the home screen, which is always important, right? You can only perform operations if you're on that home screen. So now I'm gonna recall matrix A. So I'm gonna go back into matrix A plus. I'm gonna recall matrix B, and I'm gonna add them together. So I'm gonna hit enter, and we have the solution. -1, -3, 3, and 0. So the only thing the calculator is doing is adding the first element in the first row. Is taking this 1 and it's adding it to -2. 1 minus 2 is -1. Then it takes the second the second element in the first row, -6 plus 3 is -3. And it's doing that for all of the elements in the matrix. You can also multiply matrices. Okay, yeah. So here's an example. So let's say we have A, and I want to keep matrix A the same. That's equal to 1, -6, 1, and -5. So let's say if we were to ask to find 5a, since I already have matrix A in the calculator, I'm simply going to take 5. I'm going to recall matrix A. Right. Let me just put that in the right way. 5. And then I'm going to recall matrix A. Right. And if I hit enter, it multiplies 5 times matrix A. Right. So we get -5, -35, and -25. Okay, we could also find the square of a matrix. So we have A is equal to 1, -6, 1, and -5. And let's just say we were asked to find A squared. Right, I can simply take matrix A and square it. And we would have -5, 24, -4, and 19. And then we'll do one more. We could also multiply matrices. Okay, this is similar to number 8. So we have A is equal to 7, -2, 8, and 3. B is equal to -4, 6, -8, 3, -3, and 4. Okay. And we're asked to find A times B. All right, so I'm simply going to put these into the calculator. And multiply them. Right, so matrix A, that's a 2 by 2 matrix. So we have 7, -2, 8, 3. I'm going to edit matrix B. But matrix B is a 3 by 2, right? 3 rows, 2 columns. So I must change my dimensions to 3 by 2. -4, 6, -8, 3, -3, 4. And then we could multiply. Right, so I'm going to recall matrix A. I'm going to recall matrix B. Okay. Now, I'm not necessarily putting the times because the calculator understands that that's a multiplication. Although you could put the multiplication symbol in there. Okay, but the multiplication is not necessary. I'm sorry, they want us to find B times A. Okay. And there's a reason why you can't actually multiply A times B, and I'll tell you why. Because if you're multiplying A times B, when you multiply the rows of one column, your first column has to be equal to the columns of the second matrix. Right? So if we look at this one, matrix A has 2 columns. Matrix B has 3 rows, so we can't actually multiply A times B. So it's important what you're multiplying. But we could multiply B times A because B has 2 columns, A has 2 rows. The columns and rows must match. So I'm going to put in, so that's why when I put in A times B, I get this dim mismatch. That just means dimension mismatch. But if I were to put in B times A, B times A, right, I get a result. All right, so B times A gives us 20, 26, negative 32, 25, 11, and 10. All right, so any questions about matrices and solving a system of equations? All right, so I'm going to